What is up, YouTube? Derbador Weldor here, coming at you with another video. Today, we're going to be talking about something pretty cool. And it's not these connectors, but it's something for the connectors. If you followed my channel for a really long time, this will be familiar to you. As we unroll this, ta-da! It is the Arc Pig review, take 2. Stick around. Alright everybody, so what is this? For those who don't know what this is, let me explain this to you. The Arc Pig is a high frequency generator. Now, what a high-frequency generator does in a grand scheme of things is it allows you to take a welding machine, probably mostly an engine drive or, an AC buzz box or something, that has AC weld output. It allows you to TIG weld aluminum with that AC output. Now, let me clear up a myth a lot of people don't know. Now, there's a myth going around people don't necessarily know, or people with very little experience in the welding industry know, and that is just because you have AC does not mean you can weld aluminum. You have to also have the introduction of high frequency current into your AC line. Without the high frequency current to keep the arc lit in the zero time of your AC current, because AC is positive and negative cycling back and forth at 60 times a second, which also means your arc is cutting off 60 times a second. We'll explain that in a little bit. But the high frequency generator, or Arc Pig, keeps the arc lit through the downtime, or the zero time, where your arc transitions from positive to negative or negative to positive. So we will explain that here in just a second. Alright, so let's have a little lesson in electricity. Alright, so DC is primarily now what everyone welds with, right? So DC, your electricity is flowing in one direction. So this is 0, this means no electricity, right? This is positive. This electricity flowing that way, right? This would be negative, which is electricity flowing this way. That is DC, plus and negative. Alright? You can TIG weld with both of these without the use of high frequency. The reason is, once it's lit, once you touch and light and go, the electricity never stops. It just keeps flowing because it's flowing in one direction. It doesn't have to stop, then back up, then go forward, back up, go forward, back up, go forward. Now, you can TIG weld aluminum with either of these. Yes, you can TIG weld aluminum on DC, but it's not very good. DC positive is the polarity that gives you your cleaning action, not AC current. A lot of people like to say, oh, AC, the back and forth is what cleans it. No. False. It is the current coming off of your workpiece up to your gun that cleans the oxides off of aluminum, not the back and forth. However, DC positive puts a whole lot of heat into your tungsten. Because of that, you can only weld for a very short period of time before your tungsten balls up and falls in. And also, DC positive has very little penetration. So your penetration profile with DC positive is going to be very shallow. It's going to look something like that, right? And it's going to put a lot of heat into your tungsten. It's going to ball out and fall into your workpiece. However, DC negative does not have any cleaning action. So the oxides are going to be there, and it's scummy and nasty. You can weld with aluminum with DC negative. There are ways around it. You can use helium, which is really, really, really hot, and on thick material, it's so hot, it actually burns the oxides off, and then you can weld aluminum with it. It works. It's not ideal, especially for thin stuff. It has really, really good penetration. DC negative on aluminum has a penetration profile about like that right there. It's very, very, got a lot of penetration. Very sharp, especially if you use helium in there. And it keeps a very tight, small bead that's very sharp and has a lot of penetration. That's why people like to use DC negative with steel. Well, actually, you have to use DC negative with steel. There's no point in using DC positive when you're TIG welding steel. But that's why people like TIG welding steel, because it keeps the arc very confined and gets lots of penetration and gives you direct control over everything that's going on. Now, there are pluses to both of these. We want both qualities, right? So, we want both qualities. A good way to go about that is AC. This is our 0 line right here. Now, some of you who have studied electricity and stuff like that, this might look familiar. Positive, negative. This is what AC current looks like. What? And it is doing this right here. This is called a sine wave. And it does this. Your electricity will go positive, will slope down into negative, slope back up into positive, slope back down into negative, and back up. It'll do this 60 times a second. That's why it's called 60 hertz. A lot of machines, you can adjust how many times it changes per second, which gives you even more control and all of that. But the kind of machine you'd be hooking up the arc pig to, chances are it's going to be 60 hertz. So we'll just say 60 times a second, because most machines, if it's putting out AC weld, it's exactly what your wall puts out, so it's going to be 60 hertz, which is 60 times a second. Now, if you look at this right here, it has to slope over to 0, which means the electricity is going forward. Then it's stopping completely. Then it's going back, which is this right here. It's going forward. Then it's backing up. And it's going forward. But to do that, it has to come to a complete stop. A total stop. So 60 times a second, you have no power. Which means if you light the arc, it will extinguish 60 times a second. Which means there's nothing to keep it going, because you touch, lift off, and in the blink of an eye, it'll shut right back off. Because 60 times a second is shutting off. So, the arc pig, what does it do? If you introduce high voltage, really high voltages like to jump gaps. Just like an ignition coil in your car or your truck or whatever jumps the spark gap to light the gas in your cylinder, and boom, you go. It likes to jump gaps, even on AC. That's why when power lines go down, they have extreme voltages running through them. Not necessarily so many amps, but extreme voltages going through them. And that's why you'll see when power lines go down, even though it's AC changing 60 times a second, it still arcs out and maintains arc to ground. Because that really high voltage lets it jump that gap, and it just keeps arcing over. Now, so what the arc pig does is it introduces really high voltage. And if I read the material correctly on how the arc pig functions during continuous use, is it actually introduces high frequency in a pulse. So what it does is it fires 60 times a second, or how many ever hertz your machine puts out. So the arc pig will, let's use red, arc pig will fire here, here, and here, and here, just like that, 60 times a second. If it's 60 hertz, it's 120 hertz, it'll be 120 times a second. It fires at that 0 time to relight the arc. in the negative, then relight it in the positive, relight it in the negative, and it's so fast, all you hear is wee. That is it relighting every single time, if I understand it correctly. Other high-frequency units don't do that. They're not as smart. The Miller HF251D, and Lincoln has one too, they just introduce a background of high-frequency current. Instead of a burst of it that goes poof to relight it, they just introduce high-frequency AC current through the arc that looks something like this. And that keeps the arc going. Both systems work. There's nothing wrong with either system. In fact, the Miller and the Lincoln, you can adjust the frequency of your high frequency. So you can turn it way up or you can turn it way down. The arc pig adjusts independently based on how many ever hertz your welding system is putting out. All right? So hopefully this clears up everything, and I'm going to put this up here. I want everybody to see. So DC positive, what are the things we get out of DC positive? Cleaning. We get cleaning out of DC positive, right? That's why we want DC positive. We get out of negative hopefully I spelled that right. DC negative, we get penetration. I'm a welder. Sorry. I can't hardly even spell my own name sometimes. We get cleaning out of DC positive. We get penetration out of DC negative. AC gives us both of those right there, which means we get both the positives of the two different polarities. Okay? That makes sense. That's why we want to TIG weld on AC. Now, your spool gun does not generate AC. I have to say this because I hear people say it all the time. Spool gun generates AC. That's how it welds aluminum. No. Your spool gun runs on DC positive. It doesn't matter that it puts a lot of heat into the electrode because the electrode is wire that is being spray transferred across. That's also, because it's DC positive, is another reason that you have to use ridiculous amounts of amperage with a spool gun versus if you were just MIG welding steel. That's why your charts on your machines, it'll say, it can weld up to 5/16 steel, but it will only weld up to 3/16 aluminum because of what you see right here. It takes more amps on the DC positive side to get the same penetration that you would on a DC negative side. Okay? Makes sense? And also, for some reason, I've been told that DC positive with stick mode gets better penetration than DC negative. So apparently TIG is the reverse for some reason. I don't know why. That's just how it works. Okay? So hopefully this explanation clears some things up, and now we all understand why we want the arc pig and why it's so cool. So, now that we understand why we want the arc pig and why we need this high frequency generator, there are some other things besides being able to TIG weld aluminum. It will do contactless start, which means you can hook it up to a stick stinger and get about that close to it, push the button, and zoom, it'll light. It'll jump that gap, light, and you can run. Same with TIG welding steel on DC. You can hit the button, it'll light, you don't have to touch it. However, I am reviewing this as a professional. I am a AWS certified welder. I have two current AWS certifications. I have 4 in total. I am a certified welder. I do this for a living, okay? I get recertified every 2 years. I am a professional welder. This is what I do for a living. I am reviewing this as somebody who does this for a living. So I'm going to talk about the only real reason I would use this, which is as a arc stabilizer or a high frequency generator for TIG welding aluminum off of my engine drive welder. Because if I'm in the shop, I'm going to be using something that is a dedicated AC/DC TIG machine or a spool gun or whatever. I also use spool gun in the field too. So really this is, for kind of what I do, a novelty. I don't want to say it's a novelty because I'm pretty sure we can do some pretty cool stuff with this. I don't want to say that this is really a novelty because I think we can do some really cool stuff with this. I used to have let's go over the story of my first arc pig. Alright, because if you don't already know the story. So, long time ago in a galaxy far, far away, I still had Tow Mater as my main rig truck. Tow Mater was hauling around a welding machine that was made the exact same year as he was. I had a 1979 Miller Blue Star 2E as my main welding machine because I thought, hey, an old truck, an old welding machine, what a great combo. Now everything's old, cheap, and easy to work on. Little did I know, old welding machines, parts cost way more for old welding machines versus new ones, and it's better to just suck it up and buy a new welding machine. It's not the same as owning a pickup truck. An old pickup truck, parts are going to be around forever because there's just way more of them than there are old engine drive welders. So, that being said, the Miller Blue Star 2E had AC function on it, right? I wanted to be able to weld aluminum in the field. So it had a AC weld function on it. The best way for me to weld aluminum off of that machine was to get a arc stabilizer and take advantage of the AC weld output on the machine. Since that machine did not have nowhere near enough generator power to run an inverter AC/DC TIG welder. However, my new Miller Bobcat, and as most all welding machines now, have more than enough generator output to run just about any welding machine you want to put into it that you can carry with you, right? It's 11,000 watts. You can run just about any welding machine off of that. However, the old Miller Blue Star 2E did not have nowhere near that much. It only had 2,000 watts, which is barely enough to run an angle grinder. There's only 2,000 watts, just a little bit more, because 1,500 watts is your running most tools, right? It may have been 2,500 watts, but I think it was 2,000. It wasn't a lot. It did not run a lot. I was actually able to run my Hobart Handler 100 off of it, which is really funny, running that off of there, because it did not like it at all. You pull the trigger on the thing and it's like, whoa. It did not like it at all. But it was funny. That old machine was a piece of crap. And probably contributed, because it was a piece of crap, probably contributed to the fact that my old arc pig did not work like it was supposed to. Now, I have a brand new Miller Bobcat 250 with less than 100 hours on it. It is redemption time for the arc pig. Now, let me explain the advantages the arc pig actually has over plugging an inverter machine into your welder, right? It is still substantially smaller than an inverter welding machine. I'm sure before I die, we're going to have AC/DC inverter TIG stick machines this small, right? I don't have them yet. I run a small truck with very limited storage. So something like this, you can fit behind the seat. You can fit this behind the seat. It doesn't take much. I mean, it's simple. It's small. It's lightweight. It's this big advantage over the Miller HF251. Its other big advantage is the fact you don't need 110 power constantly running to it to create the background high frequency like we were talking about. This gets all its power from your welding leads. Just like when you plug in a suitcase. The suitcase gets all its power from the welding leads. So it's very, very nice. And it uses simple parts. If the arc gap goes bad, you just go get a spark plug from Walmart and replace it. It does not require Miller specific parts. And you know, the other thing about it, it's got just some really interesting warnings on here. I love the warnings on it. Made in Texas, with parts from cheaper countries. That's being honest. Caution, this is my favorite one. For maximum safety, don't weld anything. Yes, boys and girls, that is right. Welding is dangerous. If you want to be safe, just don't weld. It has instructions on here. It even tells you how to set it up for your, if you can read through demo, your stick mode and your TIG mode right there has disassembly instructions on it. Very well built. This is not cheap. This is not, price wise, it's around somewhere $300-400, depending on where you get it, depending on what source you get it from. I think eBay still has it. The Amazon store, I haven't seen it on Amazon for a while. It may be out of stock, but this thing right here is built solid. Let me be absolutely honest with y'all, and this is not because they sent me a free unit. I don't care. If this thing doesn't work, it's going to go on my video. I'm going to send it back. Be like, hey, man, this thing don't work. We'll actually call them first and see if we can figure it out. But, you know, I'm not going to just give them a positive review because they sent me something for free, right? This is me. I'm an honest person no matter what. So, let me be absolutely honest. This is pretty tough feeling. It feels like something Miller or Lincoln made. It feels professional grade. You know, it feels, the plastic on this is very tough, good feeling plastic. It feels like the plastic casing on the front of my Miller Bobcat. It is, you know, got that, still got even that matte black look. I'm looking at my Bobcat right here. It's got the same matte black look and almost the exact same blue that my Miller Bobcat has, which, you know, is pretty cool. I like the color blue, matches my truck. But it's tough. You can feel it when you pick it up. It's tough, and it's made very, very well. So, now we've gone over that. Let's go over your ends right here. This is your torch side right here. And this is where your torch is going to hook up. So how I am setting this up is I have these Linico connectors, the twist lock connectors. I use them all the time for everything. That's how my engine drive is set up. So I'm going to set this up with Linico quick connectors. I have some tag leads here. I'll cut them into like 1 foot sections and put a lug on the end and then a connector on the other side. That way you just plug your leads into this thing and go. Now, one thing you need to do, keep in mind with this machine, or this device, not really a machine, it's a machine, it's not a welding machine, but anyway, this right here, you need to keep it as close as you can to you because you're going to have high frequency bleed. High frequency is looking for its way out, so if this thing is sitting all the way back at your welding machine and you're 300 feet over here welding, that's not going to work. So you need to set up your system to where this is right there. So where you would plug in your stick lead or your suitcase when you get out there is where this needs to go in. This needs to go in where you plug in your suitcase. Now, torch right here. This will be a quick connect for my TIG rig. Has our little what do you call this thing? Your remote. There we go. This comes with a remote. I'll show you the remote here in a second. Has your 2 connections for your remote. Probably goes to a contactor of sort inside. I haven't really done like a taking it apart and looked at it. I kind of want to make sure, see it work before I take it apart. This right here, you can see it right there. Let me turn it. You can see right there. You have one wire and another wire. It doesn't matter which wire out to the remote because all it is a continuity. So you push the button, it's a contact switch, you push the button, it connects, turns this on, you let go, shuts it off, right? So it doesn't matter which wire you plug into there as long as you plug both wires into there, right? It's just like the trigger on your MIG gun. We go over here, upside down. Have ground and power. Now, this is very important, okay? Very, very, very important. Listen to what I'm about to say. You must, when you're ground, you're going to plug your ground, or as mine is marked negative, into here, right? Then you're going to attach from this same lug, you're going to attach your work clamp cable to this. So your ground back to the machine and your work clamp cable must go into this lug. This neutralizes the high frequency that could be returning to your welding machine that could cause irreparable damage. Alright? So, I will show y'all here in a second what that looks like. Power, right here. This is where your positive side or an AC, your power side or your torch side will go in. So it goes in here, gets its high frequency, then comes out here. It goes through your workpiece to where it says ground, right here, gets neutralized, then goes back to your welding machine. Make sense? Cool. Moving on. So, anything else I miss on here? Oh, yes. Very important one. Don't drop. I know it's probably going to get dropped, okay? Anything I own gets dropped. But it says right there, drag me, dangle me, do not drop me. So be careful with it. It probably has some sensitive components in there that will not handle shock very well, okay? It also has a warning on here that says, high frequency may damage a spool gun. So don't use it with a spool gun. Why would you hook this up to a spool gun? I know they put that on there for their own liability. Say, well, let me just tell everybody, don't hook this up to a spool gun. If you have a spool gun, you don't need this. So why did you buy it? Use the spool gun. All right. What else? EMI warning. This pig broadcasts strong radio interference. This device is likely to damage other nearby electronic devices, including medical implants and slot machines. Slot machines. That's just... I don't get it. Why am I going to be using this on a slot machine? Maybe I want to get more money out of the slot machine, or I'm mad at it and I want to kill it, so I'm going to bring this in there and hook it up and, put it right next to the slot machine. Ah, die, you slot machine! You took all my quarters! Oh, yes. Warning! Flammable materials are flammable. Just to let you know, guys, if it's gasoline, it's probably flammable. You shouldn't weld near it. Lift start gives me no power. If you are lift starting while having this hooked up, something you shouldn't have bought it. What else do we have? Arcing high frequency can burn you even if it does not hurt. Wear gloves. Wear gloves. Okay? Let me tell you a story about high frequency, alright? It's back from the day I was, door-to-door to welding student. And one of the things we really loved to do at school, because it was funny on TIG Day when we were all caught up, was we would take the Miller Dynasties and turn the amperage way down. Then we would turn the high frequency, the hertz for the high frequency, way up. And we thought it was really funny to hold the tungsten in one hand like this and point your finger at the grounded welding table and mash the pedal. Because what would happen is you get lube in your arm and you could shoot lightning from your fingers at the table. It was pretty cool. Very dangerous. One mistake and, somebody could have gone into cardiac arrest. But we didn't know. We didn't care. And some of them, not me, were too drunk or high to care. And probably getting a little high frequency right there first thing and went, woo! Would knock them out of their hangout or drug partial addiction. So, don't screw around with high frequency. It's bad for you. It might not kill you, but it's bad for you. Okay? Oh yes, this is my favorite one. Gravity hazard. This device may cause injury if dropped from a height. Yes. There's a lot of stuff that needs a gravity hazard symbol on it. I think all my tools and my truck and everything needs a gravity hazard warning on it. This is very important, guys. Stuff that falls from a height that hits you in the head can hurt. I think we should all start a petition to get these warnings put on stuff. What else? Beep codes. This is a really cool thing. It kind of has its own, troubleshooting built into it. Beep. One beep. Startup calibration. Chirp. Needs a spark plug. Steady tone, fault. Music, overheated. That's cool. So this will at least tell me something. The Miller HF251D won't tell me anything. And I've owned a Miller HF251D, and I've owned this. So I can say I am kind of an authority on these. Alright? So, Torch is live. This is a very good one. Torch is live. This device cannot block weld current. Very, very important that we understand that this device cannot block weld current. It does not have a contactor in it, guys. So this thing right here, you're going to have that AC power still going out, or that DC power if you're using it for a lift start, for not lift start, but an arc starter. That power is still going to be going through that torch. There's no contactor to stop it. Okay, this ain't like a spool gun controller where it's got a contactor in there. You hit the start and it goes wee, and it connects. The torch is still live. That's a really good warning. I'm glad I looked through and saw that. All right, maintenance. This does have a fan in it, so you can see there's a little ventilation right here. And I think there's one down here. It's got a fan, so maintenance, clean blower, which would probably be, oh God, maintenance. Oh, these are great. Maintenance, blow it out. Inspect insulation. Very important to inspect your insulation right here. This is very important because if you don't have good insulation on here, your high frequency is going to bleed out and it won't work. Inspect insulation, tightening nuts. These nuts right here might come loose, which will cause it to arc, which will cause you to lose high frequency because your high frequency is being spent where this is arcing instead of out where your torch is. Okay, what else? Send flowers. Apologize daily. Apparently, whoever designed this has a wife. Send flowers. Apologize daily. Yeah. Whoever made this has a wife. So, now that we talked about all of that fun stuff, let's set it up and run it. Okie dokie. And a hammer. Now, hold it there. All set up. Probably could have cut the insulation back a little further on this one, but it'll still work. And we smack it. And we smack it again. And we smack it again. And having my camera on the same table that I'm smacking the crap out of might not be a good idea. But, pull it off. Look at that. Got a really nice crimp on there. So that's good. Now we should do that 4 more times. Now that we've hammered the lugs at a slight angle, we can hook these up. And it's starting to look like a welding wire disaster zone. It really got a look to it for sure. Gonna tighten that up. You don't want any loose nuts. Remember that. No loose nuts. Try to keep everything as tight. Pretty, and neat looking as possible. You can see right there. Looks pretty clean. Now the torch on the front here. Now we gotta make sure we have room for, you know what, I'm gonna bend this one in the vise too. I think it'll help it come out at a better angle, like out here, which will give us room for our remote. Now, a much better angle on that than we did before. And also, I have this is set up a little bit better than I originally had my old Art Pig set up. We'll say this is, check that out, much better setup than my original Art Pig. I did not have a dedicated plug for the torch. I kind of just rammed my connection block for the TIG torch in there, and that's probably not a really good idea. So now that I have an insulated connector for the TIG torch, and the TIG torch connector also has an insulator on it, this system setup might actually work much better.